Discriminant and the nature of solutions. Let's recall the quadratic formula. X equals negative b plus or minus square root of b square minus 4ac divided by 2a. So this formula will give us solutions to any quadratic that is written in the standard form. Ax square plus bx plus c is equal to 0. So if you want to know what x satisfies this quadratic equation, then there are actually two numbers. And you get those two numbers by plugging in the values of a, b, and c. Now notice in particular that this quantity b square minus 4ac, that's under the square root, this quantity will decide if the roots are going to be real or imaginary, and if they are real, if they are going to be same or distinct. So this quantity is called discriminant. Now sometimes students confuse that discriminant is square root of b square minus 4ac. No, it's not. It's just b square minus 4ac without the square root. So what happens if discriminant is positive? So if b square minus 4ac is positive, positive means greater than 0. That means your solutions are negative b plus square root of b square minus 4ac over 2a, and the other solution is negative b minus square root of b square minus 4ac over 2a. So these solutions are going to be real and distinct. Okay. Why? Because one of them uses the plus in the numerator, the other uses minus in the numerator. So notice they have the same denominator, but now if b square minus 4ac is positive, then square root of b square minus 4ac is also going to be some positive number. So say if this is 2, then the numerators are different, because here it's negative b plus square root 2, here it's negative b minus square root 2. That makes it distinct. So that's first case. Now b square minus 4ac is a real number. What if b square minus 4ac equals 0? In this case, notice the denominators are same, but the numerators will also be same, because I'm going to add square root of 0 here and I'm going to subtract square root of 0 there, which means I'm not adding or subtracting anything. They both are negative b. So here I will say that the solutions are real and equal. And what are those solutions? Negative b over 2a and negative b over 2a. So you have the same solution that will appear twice. Now in mathematics, we use the word distinct to mean different. Then in third case, a real number could be either positive, 0 or negative. And that's all a real number could be. So if we discuss this, then we are good. So if b square minus 4ac, if the discriminant is negative, that means you have negative under the square root, which means you are going to have imaginary solutions. So solutions are imaginary And in fact, I can say that they are complex conjugates. Complex conjugates. So let's actually write down the solution. Negative b plus square root of b square minus 4ac is, okay, actually let's go ahead and simply write this down. Negative b plus square root of b square minus 4ac over 2a, and negative b minus square root of b square minus 4ac over 2a. The fact that b square minus 4ac is negative tells me that the square root will be imaginary. But notice, these denominators are same. The numerators are again just, one would have a plus, the other would have minus. So that's why it would lead to complex, the solutions are going to be complex conjugates. Now we'll do some examples and then you can see. So let's write down our first example. Example 1. So find, or let's say find the discriminant. Let's title, because that's all we'll be doing. X square plus 12x plus 35. So if you have a quadratic expression like that, then a is 1, b is 12, and c is 35. Now notice, you may be given a quadratic expression or a quadratic equation. So let's say you have a quadratic equation. Now you don't have to find the solutions, you only have to find the discriminant, which means you're doing b square minus 4ac, only a small part of the quadratic formula. This is 12 square minus 4 times 1 times 35. And we follow the order of operations. We do all the multiplications or exponent, and then we carry out the subtraction. 4 times 1 times 35 is 140. So this is 4. Now 4 is greater than 0. So I can say that the solutions are real and distinct. Look, I did not find the solutions. I could have actually found the solutions quite simply here by factoring. But that's not the goal. The goal is to find the discriminant and comment on the nature of solutions. So if you get a positive discriminant, then you know that the solutions are real and distinct. Let's look at this example. X square minus 6x plus 9 equal to 0. So this time a is 1, b is negative 6, and c is 9. So b square minus 4ac is going to be, I got to square negative 6 minus 4 times 1 times 9. So this is 36 minus 36, which is 0. So if the discriminant is 0, that means the roots, or sometimes I use the word root. Root is the same as solution, so they are interchangeable. So this time I'm writing roots are real and equal. Now, I also want to tell you that in the previous problem, if you actually went ahead and found the roots, you would factor this as x plus 7, x plus 5, and then the roots or solutions would be negative 7 and negative 5. So they are two distinct roots. Now here, if you were to factor this, you get the same factors, x minus 3, x minus 3. And your solutions are going to be same, x equal to 3, x equal to 3. Sometimes you say that there is only one solution, or sometimes you say that I have a double root. Now let's look at one more example. So this time I'll just say example 3. let me just take x square plus 4 equal to 0. Now, I have to be careful in writing the values of a, b, c. A is the coefficient of x square, which is just a 1, and b is not 4. B would be the coefficient of x, and if I don't see x at all, if the x term is missing, that means the coefficient of x is 0 or b is 0. Now what you see is actually c, which is the constant term. So I have a equals 1, b equals 0, c equals 4. And now if I compute the discriminant, I got to do 0 square minus 4 times 1 times 4. So this happens to be 0 minus 16, that's negative 16. Now negative number is less than 0 and the solutions are imaginary. The solutions are complex conjugates. In fact, how would you solve this? If you were to solve, you subtract 4 from both sides and then you use the square root method, which is x would be plus or minus square root of negative 4. When you subtract, you would have negative 4 on the other side. And what is square root of negative 4? It's 2i. So your solutions are plus or minus 2i. And notice, they're complex conjugates. And I think these three examples are good for this particular video. And let's review what we did. And why we are doing it. So we recall the quadratic formula. Quadratic formula will give you the solutions of any quadratic equation in the standard form. And if the quadratic equation is not in standard form, you can always write it in the standard form. But sometimes you are not interested in knowing what the solutions are. You just want to know if the solutions are going to be real, imaginary, and if they're real, are they going to be equal or would you have only one solution? So in that case, we looked at this quantity under square root, and that's given a name, discriminant. And depending on what that discriminant happens to be, it could be one of the three situations. Discriminant could be either positive, 0, or negative. And depending on each of those cases, you have different conclusions. And now, let me write down a few practice problems. I already have them written here. So find the discriminant of the following quadratic equations and state the nature of solutions is what these exercises are about. So there are 10 of them. Now, be sure to write down the values of A, B, and C. So sometimes you may not have three terms, in which case you want to know which one is missing. So here, for example, A is 1, B is missing. So B is 0, and C is negative 4. And in 8, you don't have the constant term. So A is 2, B is negative 7, and C is 0. So again, there are only two terms here. So be sure to use the proper values of A, B, C and find out the discriminant and then state the nature of solutions. So I'll have the answers to these practice problems in the video description. And that's all I have for this video. I'll see you in the next one. Thank you.